Today's lesson will be a review of osmosis. Here we're looking at the cell membrane, just a segment of it. Okay, and here we have something called an aquaporin. These are little tubes, protein channels that water can travel through the cell membrane. Osmosis is a passive transport. It only moves water. It uses these special protein channels to move the water because the hydrophobic tails don't like water. That's these guys here. Water moves from an area of high concentration to an area of low. So these are little water molecules here. They look like upside down Mickey Mouse. H2O. So what is high concentration? Well, if I count up the water molecules here, maybe this is inside the cell. I see 1, 2, 3, 4, versus on this side, which may be outside the cell, there's only 1. Where is water the highest? Here, inside the cell. This would be low concentration. There are less water molecules. This is a type of passive transport, so it doesn't need the cell's energy. High concentration is here. Low concentration is here. The water molecules like to move from an area of high concentration to an area of low. So these water molecules are going to travel through that protein channel until equilibrium is reached, where you have an equal amount of water on the inside or the outside of the cell. Memory clue for osmosis. You could think osmosis starts with an O. H2O moves water. Now we have certain types of solutions. The first type of solution we're going to look at is called hypertonic. What's a hypertonic solution? Let's take a look. First of all, these little black dots here are called solutes. These are molecules. They can be sugar, they can be water. They can be sugar, salt, and they are in water. This is the cell, the circle. You have inside the cell, you have outside the cell. I see water molecules here, and I see some form of solute. So where is the area of high solute concentration? All you have to do is count up the black dots. Wherever you see more, that is high solute concentration. So on the outside, I see 1, 2, 3, 4, 5, 6, 7, 8, 9. On the inside, I see 4. Solute concentration is highest on the outside of the cell. Where is the area of low solute concentration? Inside the cell, there are less black circles. So if you had a paper like you would in class, you would label this high solute on the outside, low solute on the inside. All right, where is the area of high water concentration? Well, if there's low solute, that means think about having a drink of a sugary drink. If there's not a lot of sugar in there, that means that there's low solute, but there's probably a lot of water. It probably tastes like watered down. So if we were to count how many water molecules there are here, 4, 5, 6, 7, 8, versus how many are on the outside, only 4, this is where water is the highest. Think about a drink being watered down. That means there's low sugar content in it, or salt, or whatever it is, and high water. So inside the cell, where is the area of low water concentration? It's on the outside. You can count up the water molecules. You see that it's on the outside of the cell. All right, now we're only going to focus on the water molecules. What you will do is ask yourself, where is water highest? We already said it. It's inside the cell. So you would put your pencil or your pointer and know that these water molecules are going to want to move out. So how will the water molecules move? They move from high concentration to low. So in this case, they're going to move out of the cell. And you can draw your arrows to show that the water is going to move out of the cell. Let's take a look at the definition of hypertonic solution. It's a solution with a high solute concentration, but a low water concentration. So we drop this cell into a jar, just like I did with my eggs experiment. All right. The opposite, though, happened with the vinegar. The water rushed in. We're going to look at an example like that. But let's say we drop this cell in some sort of solution. In this case, the water is going to move out. So in a hypertonic solution, what's going to happen? When we place a normal animal cell into a hypertonic solution, what's going to happen? You have a high water concentration inside the cell. It's going to shrink, okay? So there's a low concentration of water outside the cell. It causes the cell to shrink because the water wants to leave. How about on a plant cell? You have high water concentration here inside the cell, low water concentration outside the cell. It causes the plant cell to plasmolyze. This means that the water inside the cell leaves, but the plant cell isn't affected as much because the cell wall helps to keep the same shape. Okay, you still see that it's kind of like squeezed in. So what's our memory clue for a hypertonic solution? Think hyper, skinny. Why? Because think about hyper people. They have lots of energy and they are active, fit, and they are sometimes skinny. So when a cell is placed in a hypertonic solution, what will happen to it? It gets skinny or it shrivels up. So hypertonic, hyper people, they exercise, they get fit, they get skinny. That's what will happen to your cell if you drop it into some sort of hypertonic solution or if it ends up in a hypertonic solution in the body. How would we tackle